Hello again, this is Kasia, and this will be the continuation of implicit differentiation. We did check through the explicit way that derivative of the function square root of 25 minus x squared is defined like this. Negative x over square root of the quantity 25 minus x squared, and respectively for the negative, because we did solve the equation of the circle we solve for y, and we did get positive and negative. We did get the upper and the lower circle. However, we also took the general equation, x squared plus y squared equals to 25, and we did use our new method, the implicit differentiation. And our answer is, for the derivative of that curve, slope of the tangent line, of course, it's negative x over y. We also notice that the answer is in terms of x and in terms of y. And we still remember function y depends on x. And we did compare this form and this one, and we know that they are the same because the denominators are simply the y function. Normally, we will keep the most general form, x over y, but since we did have y in this case, we did substitute. Okay? But this is not the case always. We will leave it the answer in terms of x and y. Oh, I did have the answer. And that we can see all of these equations, all of these derivatives are the same. Okay, that's me. Now let's actually try to differentiate implicitly, and always having an expression, having an implicit formula, we have to remember that function y depends on x. X is independent variable and y depends on x, dependent. And we will simply take equation like it is. We will differentiate both sides with respect to x, and then we will solve for dy dx. And of course, the final answer will be in terms of x and y. And let just remind, like let's do this. Derivative of x squared, of course, is 2x. But if we will differentiate y squared with respect to x, we will follow the power rule. However, we have to remember behind y, we have the function which depends on x, which will be following the chain rule. We will multiply by the derivative of y. That means, one more time, derivative of y squared is 2y times y prime, or dy dx. I can say dy 2y times y prime. Okay, that means please remember dy dx. Okay, and let's take this equation. We remember x cubed plus y cubed equals to 6y. That was a little bit crazy. We do remember, and it's almost, I mean, it is possible to solve for y, but we remember it was huge, 3 equations. That means we will not do this. We will actually apply implicit differentiation. That means part A is asking to find y prime, which is dy dx, and then we can find the equation of the tangent line to that curve. This curve has a name, and it's called Folium Descartes, okay? And we remember it's just a nice loop. Okay, but I will remove this. And the tangent line at the point 3, 3. Okay, let's do it. Of course, in order to get the tangent line, the slope of the tangent, we need the derivative. So I will take this equation and differentiate with respect to x, the left and the right hand side. And now, derivative of x cubed is 3x squared. Okay, we can see this, 3x squared. Derivative of y cubed is 3y squared times dy dx. And on the right-hand side, we have to be careful because we do have a product. Okay, that's we have 6x times y, product of two functions. In order to differentiate, we will use the product rule. Derivative of 6x is 6 times y plus 6x, and derivative of y is dy dx, because we remember it's not just 1. That means this is the derivative of 6xy. Okay, let's take this equation and solve for dy dx. I will keep that part of the of this on the left-hand side, and I will subtract this from both sides. Okay, and then 6y I will keep on the right-hand side, and I will subtract 3x squared. And then I can factor out dy dx, and I can divide both sides by 3y squared minus 6x. One thing that we may notice, the common factor is 3. 2y minus x squared, and I can factor 3y squared minus 2x. Okay, then I can cancel out, and this is the derivative of the curve x cubed plus y cubed equals to 6xy. Okay, now, of course, we can see that the final answer, the derivative, is defined in terms of x and y also. And this is sometimes for some complex applications, sometimes this is additional thing for us, additional job to do to compute y. Okay, but in our case, we have this derivative and we have to find just the slope of the tangent line at the point 3, 3. Point 3, 3 means that this is x, this is y. Let's just substitute instead of y3 and instead of x. And this is 6 minus 9, 9 minus 6. This will be negative 1. Okay, and then point slope form. This is y sub 1, this is slope, and this is x sub 1. X and y is 3, 3, and of course slope is negative 1. When we get the slope intercept form, we have negative x plus 6. That means this line is equal to negative x plus 6. And makes sense, the slope is negative. Okay, find dy dx for the equation x cubed minus xy plus y cubed equals to 1. Of course, we will use the implicit differentiation. I will differentiate, let me actually write down. Okay, I will write down for you. So means first of all, we will differentiate the equation like it is with respect to x. X cubed minus xy plus y cubed. And then I will differentiate with respect to x, 1. Derivative of x cubed is 3x squared. Now we have x times y, product. Let's see. Derivative of x is 1 times y plus derivative, just x, derivative of y will be dy dx. And we have to keep parentheses because we have negative in front. And derivative of y cubed, it's 3y squared dy dx. And derivative of 1, of course, is 0. 3x squared minus y minus x dx, dy dx, of course, derivative of y with respect to x. Oh, I need a red color. Plus 3y squared dy dx. And let's solve this equation for dy dx. We will keep negative x dy dx, and we will keep 3y squared dy dx on the left-hand side. and I will add y and subtract 3x squared from both sides. Let's factor out dy dx. We will have negative x plus 3y squared. I can copy right-hand side, and the final answer for the derivative is y minus 3x squared over 3y squared minus x. I just switch the order. Okay, that means this is the derivative using the implicit differentiation. Of course, the answer is in terms of x and y. Okay, let's do another one, a little bit of practice. Or maybe you can practice this one. Okay, you can pause the video now and you can try to find the derivative dy dx. Okay, I hope you are pausing the video, and please take time, please differentiate, remember about the product rule. Okay, and I can show you the solution. That means after 5 minutes, maybe, you can resume the video and check your answer against this solution. Okay, and I hope you did get that answer. And let's solve one more with me. We can do this one. This is multiple choice. That means one of the options provided is correct, but we don't have to investigate the options now. Let's focus on the equation. Y squared times, x squared times y minus x y cubed. Of course, we do have a product. Let's differentiate with respect to x squared times y minus x times y cubed, and of course, the right-hand side. Derivative of x squared is 2x times y, times the second function, plus x squared, and derivative of y is dy dx. Minus, we have to be careful, product rule. Derivative of x is 1 times x cubed, plus x, and the derivative of y cubed is 3y squared dy dx. Times derivative of y, dy dx. And derivative of 8 is, of course, 0. Derivative of 8 is 0. Okay, that's when we do have 2xy plus x squared dy dx minus y cubed minus 3x y squared dy dx equals to 0. So we will keep, because we have to solve for dy dx, I can keep x squared dy dx on this side minus 3x y squared dy dx. And then I will add y cubed to both sides and subtract 2xy. And factoring out dy dx, we have x squared minus 3x y squared equals to the right-hand side. And the final answer is, we will divide both sides by x squared minus 3xy squared. And the right-hand side will stay like it is. Okay, and I see that my option A is the correct option.